Vision Net Zero Emission. From diesel-run trains to cleaner energy in environmentally critical terrain. Joining us on stage is the Head of Design, Traction and Power System at DB E&C. Please put your hands together for Mr. Amit Vaishnav.
Good afternoon all. Thank you organizers and a kind regards to the speaker and delegates in this forum. I'm Amit Vaishnav. I have expertise into traction and simulations. I work with DB Engineering and Consulting in Bangalore. In DB Engineering and Consulting, it's one of the companies of DB Eco Group in Germany, and we started our operations in Bangalore 10 years back. Since then, we have delivered several projects in India and abroad. So we do feasibility studies, concept engineering, value-added engineering, and one of the concept studies and feasibility studies we did for our client, for a mining industry, to achieve their mission of net zero emission. And I'd like also thank Mr. Chanukya to setting up the context and stage for sustainability, which is the need of the earth. Thank you. So I would say that diesel is still being the primary source for transportation for the mining industry, and there are obvious reasons that diesel is still cheaper for many countries. Mining industries are private entities, and the capital infrastructure of the initial cost is a burden to the mining industry. But still, why the transition of cleaner fuel is required? So there is a world data map or the world data study which says that out of all the industries, even transport industry is one of the contributor to carbon emissions year on year. And switching from diesel to the cleaner fuel will also introduce good operational benefits and also a lot of cost value added to it. But yeah, there are challenges which we came through when we did this study. So the upgradation for the mining industry will require interruption to the productivity, which is very important for their revenue. Also, the geographical and electrical supply limitations are there because the mining industries run from forest to the port, which is geographically terrain is very critical there, and we do not have the grid substations all over through the corridor. So on the screen, through a video, you can visualize the length of the train from a mining industry. We did a study for our client, which is largest mining company in the world, Vale in Brazil, and we did a feasibility assessment for the net zero emission targets for the company. So the Vale had very critical ambitions and commitment to reduce their carbon emission by 33% by 2030 and to become a complete net zero company by 2050. So we did a power shift study. We started from due diligence. We did the technological review. We did what will be the cost of sustainability, what kind of value added engineering can be involved to give a cost optimized solutions. And finally, we also did a roadmap for them to implement these solutions. Just a snapshot of this project. The project is 900 kilometers long with the terrains through the forest where grid availability is not at all there. The length of train that we evaluated was of 4.5 kilometers with 440 wagons involved. And yeah, there was also a very high altitude 180 kilometer of ghat section which needed a helper loco to be pushed to push the main train. These are the scenarios that we evaluated to make a transition from diesel to electric or to other options. So the scenario 0 is business as usual, which is for diesel. One scenario we evaluated which was complete catenary based. That actually is not feasible, but yeah, another one is complete battery, wherein the charging will be done at the port and to the mine and through the intermediate stations. Another scenario that we evaluated, which was through swapping of battery tender wagons, swapping the battery tender wagon at the given locations. But what actually seemed working is the hybrid model. Hybrid model with diesel train, converting them to a dual traction mode engine through diesel and through electricity. So you can see that wherever we can have a feasibility of grid supply, we made that section with catenary, and then the non-catenary or non-electrified sections are running on diesel, which is an immediate solution for them to reduce their carbon emission. But another scenario, which was very challenging for us also to evaluate, that we did a hybrid scenario where the battery tenders are coupled with the engine, and batteries are getting charged through the OCS during the run itself, and when the non-electrified section is coming, then batteries are providing the supply. So this we validated through traction power simulation. We used software as OpenTrack and OpenPowerNet, and you can see on the map that the yellow colored corridor is the non-electrified section, and only small sections of the colored ones, blue and red, are the electrified sections, on which we have to ensure that the train travels with an optimum speed, that the complete battery is charged from 25% of state of charge to 90 or 100%, and then also to optimize the non-catenary section, non-electrified section, that the battery is having the capacity enough to complete its run before the charge is finished. The analysis and optimization was done for traction power demand and energy, so that the grid can increase its capacity, timetable optimizations, techno-commercial analysis as well, and state of charge of battery, which is very important to evaluate that the battery is fully charged, and also the battery is drained. Before the battery is drained, we finish the non-catenary section travel. The major challenge that I felt during the modeling of this network was, on the run, there were two pusher engines which were coupling, which they call as a dynamic coupling. They do not want to compromise on the productivity, so they do not want to stop the train before the ghat section. The 4.5 kilometer train, it's very difficult to stop and again restart before a ghat section. So what they did is they on the go, when the train is running, two pusher engines are, sorry. Can you help with the full video? Full slide, sorry. The full slide. Yeah, that's fine. Yeah. So you can see that on the run, if the train has to couple, the two pusher engine has to couple, the train may derail. So there is a laser guided correlative speed based mechanism which both the drivers will coordinate, and through the laser the pusher engine will couple dynamically, and this was to be modeled in the traction simulation as well, that when the train starts from its source in the mid section before the ghat, I need to produce two more engines and then again decouple it. Few outputs from the simulation and the value added engineering that we did through optimizing the battery, optimizing the feeder stations, and overall costing. So finally, the roadmap which we recommended to our client is there are two stages of implementation. First one, do a dual mode transition through diesel and electric, and use the same loco and change it to electric versions as well. And then finally, completely do the transition to the final with the battery plus electric loco. With this two-stage roadmap, we could achieve 2030 target of 33% reduction, as well as by 2050 the company should be able to achieve its net zero emission targets. Yeah, that's all from my end. If you have any questions, I'm happy to take it now, or maybe I can meet you later, or you can write to us, either of us, to DB for your queries and interest on this. Thank you. Thank you.
And to thank you for your time and your valuable insights, I now request Mr. Rajesh Maheshwari to kindly come forward and present a small token of appreciation. Well, the gentleman, Mr. Amit Vaishnav, would love to welcome his team on the stage as well. So, requesting his team to kindly join us. We do understand that everything that a representative presents on this particular stage is a team effort, and that's exactly what we'd love to celebrate at this moment. Just that
wonderful idea and very thoughtful and a great exhibition. I really congratulate not only for organizing this thing.
यहाँ पे आने के बाद मतलब 2 दिन हमने स्पेंड किया और 2 दिन में हमें काफ़ी सारे अच्छे क्लाइंट्स मिले। इवन सम हमें रेलवे की भी कुछ ऑफिसर्स मिले।
When we had installed our stall, We were getting all the supports, all the manpower, all the equipments and tools that we needed. It was really pleasant experience over here.